Hello, Michael. Can you hear me?
Oh, yep. Kind of lonely on here,
Yeah, it is a little lonely. I wasn't sure what to expect. I think there's a certain amount of hangover from the last week.
but I didn't see any notice that the meeting was canceled or anything.
I did not. Um, but anyhow,
I guess we can wait a bit and see if John shows up.
we could. So while we do, why don't you give me an overview of nVent's product solution set? What's your interest in uh, door heat exchangers, cold plate, whatever?
Um, In-row coolers, rear door heat exchangers. Let's see, CDUs. Um, uh, all pretty much anything that's liquid cooling. I don't think that we're making any cold plates themselves. We've got partnerships with other companies for in rack CDUs, and we make some monstrous CDUs that are, I think, megawatt capability.
So,
So I
yeah, I wouldn't mind an over. Well, there's two aspects of interest. One aspect is an interest is what I've been trying to campaign with Open Compute for the past year or so is the concept of well, give you an example. In most cases, cold plate is, in my perspective, delivered as a very proprietary solution set right now. And as we start going to cloud scale, the interest in looking at, say, three potential vendors of CDUs and multiple vendors of distribution methodologies um, is a potential interest. Does that make sense to you, what I'm saying? Or do you agree
well,
with what I just said?
so the major issue right now is whether the data center will let you have facility water or not. And I don't think all data centers are ready and willing to let you tap a CDU into the facility water, because the facility water is running the cracks in there. And if it's an older data center, it was set up for air cooling,
Yep.
and they don't want you fiddling with the facility water. So in that particular case, we've got a product. Um, I don't know how public it is, but we have a cabinet product that has pumps and a giant radiator in it, and it's intended to go to cold plate
So
cooled servers.
so you make does that sound like the AALC product that we're hearing about, or does that make sense to you?
It
There was
doesn't make sense to me.
there was a advanced air liquid cooling proposition put out by has been presented at OCP for some about the past 2 years, and it describes very much like you do. You have liquid cooled IT,
Yep,
and you in essence put we'll call it a radiator on the
yep,
side because,
that's what we've got.
and you dump heat in the traditional environment, and
Yep,
that is what I tell people. Number one, I believe that's been the transition mode announced
in,
by Meta and others, is until
in,
we figure out what.
until a facility will let you have water.
Right.
And then
And
at that point, you could yank the radiator cabinet and replace it with a CDU,
yeah.
and then still have liquid cooled IT equipment. And in that case, you would still run um, glycol water mix through the cold plates, but it would run over to a CDU for the IT loop, and then you would run the hantavirus water through the other side of the CDU, and you wouldn't dump anything into the air in the computer room in that case. Well, you'd probably dump 10 or 15% or something of the total IT load into air, and all the rest of it would go into water.
So, kind of moving as we go forward on this, you're familiar with what Victaulic does?
Somewhat.
Okay. Fundament, give you some background. I was in submarines, and then about 20 years ago, I joined APC, and I was a director of systems engineers, did power cooling, racks, air monitoring, and management. So, to that extent, a lot of the products that you just described is very familiar to me.
You said
Um,
APC?
APC and then Schneider. So,
Yeah. Well, APC had as a factory about 5 miles from here, or had, that made UPSs.
so where are you at?
Rhode Island.
Okay. No, I used to go to the what is it, West Kingston headquarters
Yeah.
on a regular basis. Okay.
Yeah. Yeah. That's
Uh,
just a few miles from here.
yeah. Um, my role with OCP has been trying to look at how to. By the way, got Benny Bray on the line. I didn't see you jump in there, Benny.
He's not talking to us.
Hey, can you guys hear me?
Yep.
Yeah, so I'm not sure there's any leadership on this call. I was just kind of using this time to pick the brains of Michael on what Invent does, and then
Oh,
we had you jump in. And in essence, one of the things I was looking at is maybe advancing the discussion. There's a couple focus groups that I'm going to be launching to see if they want to become work streams. And one focus group was on uh, filtration and the water requirements for the TCS, if you will. Does that sound like a focus group of interest to you guys?
I'm more on the electronics and the management side than I am on the plumbing side.
Okay,
yeah, that's
Benny.
something for yeah, that's something for us that we would be interested in.
Okay, Michael, who from nVent would be interested in the hydronic side of what we just talked about?
I would have to get you a name.
Okay.
Uh,
What I'd like to do, and I kind of jumped on. By the way, I'm officially hijacking this call. If you guys are want to leave, you can. I was just actually I joined, but I don't see any other leadership joining in, so I was just going to chat on that.
Yeah, it's
I'll
odd.
take.
There's nobody on here. That's a little odd.
Yeah. So I'm trying
Okay.
to think if there was some sort of an announcement that didn't get uh, didn't get reflected in the calendar invite.
No, I haven't seen anything, and I looked yesterday on the OCP's schedule, and this call is listed on there.
Yeah, in fact,
Okay.
they sent out a reminder yesterday for this call. So, okay. Interesting.
Okay.
Okay.
Well, I may ping on both of you. This is something initiative that actually came out of walk around last week. I started talking to people about, and one of the common themes is, can we create a cloud scale open TCS? Is it possible to, once you put in a pipe solution, could you reuse that same pipe solution for door heat exchangers as for cold plate? Um, and because fundamentally, I don't see, if people are going to go to megawatts of liquid distribution, I don't see them ripping out megawatts of liquid distribution when they decide to go to a different product set. If they go from one cold plate to vendor and say, oh, we want to use a different cold plate vendor, or we
Sure.
want to use cold plates plus store heat exchangers, they're going to try to figure out how to um, use their loop. And I
Right.
guess, does that make sense?
Yeah, I would
Yeah.
expect that somebody who's making a cabinet full of liquid cooled servers would have a manifolds inside of it, and it doesn't really matter where the cold water comes from, either a CDU or a radiator or something like that on there. All they need to do is be able to dump certain number of kilowatts of energy into the water.
Well, the smaller the footprint, the more open it, the less need it is for being an open solution. If you're just talking an IT rack, you can use any fluid you want. You can use any number of delta T's you want. You have a heat exchanger on the IT rack, and it can plug in pretty much anywhere. But as soon as you start talking a liquid loop of, say, a 4-inch pipe with, or a 6-inch pipe, distributing the equivalent of a megawatt worth of cooling, you're going to want to have a certain harmony. And as you, for example, get 3 bidders putting in cold plate, the liquid requirements, one thing that hit me last week was filtration. Filtration is not well defined, but you have ASHRAE put out a document about 4 or 5 years ago that said something like under 100 micron. And then you have another document put out by LBNL that says 50 micron. And now I'm hearing through people saying, oh, I got requirements for 25 micron.
Yep.
And that's, does that sound familiar to either of you?
Yep. It depends on
Yeah.
whether they're
Yeah.
running microchannel for the cold plates or not.
Well, it does. And so here's the deal. What I was curious is, does putting this kind of a discussion in writing to share it with people, because the strategy on how you do filtration down to 25 micron, or actually the entry point, I think, wants to be down at 5 micron. And the CDU design and the whole, actually, everything gets affected. If you start looking at 25 micron, how you do your job site construction, everything's going to have to be off site. It's going to have to be pretty clean. You're going to put it in place. It's still not going to be that clean, but you don't want to be doing job site construction of your hydronic system. You're going to want to have everything kind of snap together. This is maybe my opinion, but the aspect of any kind of maintenance introducing much greater than 25 micron contamination is means that every time you change your filters, you're going to have an MOP and SOP on how to do that in a way that doesn't increase your contamination in the process of changing.
And again, if you've got microchannel cold plates on there, you could clog the microchannels very, very easily by having poor procedure for changing your filter.
So I guess the question is, do we think the entire world understands this, or do we think is there a document that already kind of gives guidance in this, or is this an area that OCP should take leadership?
I haven't seen anything, but I think it could be a white paper or something like that, or best practices or something like that, that talks about what can be done and when give some guidance on what kind of cold plate cooling you've got versus what kind of fluid conditions you need.
Okay.
Now, there's also a group that's working on the coolants themselves. Does this kind of thing get added into the coolant requirements?
Yeah, let me just show you some things that I was working on real if you have a moment or two. If this is interesting,
Uh-huh.
I don't, but I'm very interested. What I'm interested is using this as a pre-call to set up a focus group that eventually will become a work stream.
Yep.
And so as we start looking at some of these things, what are we looking at here? I'm finding a paper that I was hold on a second here. Gosh darn it. Oh, here we go. I'm gonna go back and share a screen as we jump through some things. There we go. Okay. This is a presentation I've been building over time with the ACF group. Open Path, talking about what's driving the movement to liquid cooling. By the way, a lot of this stuff was done with AI. Here's what we're looking at is the concept of going boutique to cloud scale. And that's kind of what we're talking about right now is the concept of, in essence, going from I'm going to make one really good megawatt solution to I'm going to have to deploy hundreds of open solutions that I can add anything to. This is what we're seeing. The demand is coming in. And people start talking about 2.1 gigawatts. That's 2,100 CDUs. It's 32 miles of headers. It's 84,000 branch lines. Can we do anything to make sure that those aren't tied into an open, or they are available? So we're looking at this concept of Lego distribution and putting things together, which means, somehow the CDU has to match the IT box. And how do we do that? And that would be an area for, do you make CDUs adaptable? Do you set up a standardized set of requirements for cold plate? And the cold plate vendors generally are pushing against that.
Yeah, I would think that you would start at the cold plate because
yeah,
it's the cold plate that's really driving the filtering requirements.
and that's why this is not necessarily the correct call to be talking about, but there is a discussion on hybrid, which is basically taking cold plate plus door heat exchanger. But where this is, I'm going to skip over some of these slides. You start talking about liquid considerations, and so I shared this with people on: do you just use water with inhibitors?
But there's a whole group just for this.
A whole group just for what?
For the coolants.
Well, when you say which coolants are we talking about?
Anything other than water.
So what I'm seeing is pretty much everyone, if you start looking at and Benny, I don't know if you want to jump on this, but when you start talking large scale distribution, nothing comes close to water or water-based liquids for transporting heat. If you're dealing with inside the IT rack, you might work with dielectrics and small volume distributions. But if you're working with large volume distributions, this is what we're seeing here. Is you've got water at specific heat is 4.18, PG25 is 3.87, and then the dielectrics are basically half of those numbers. Okay.
Yep. So water is untreated water is a bad idea.
Yeah, with this work stream, but the work stream is not necessarily for the coolants. The work stream would be in regards to how to keep your secondary fluid network clean, right?
Well, yeah. So that's what. But first, we have to, it's kind of starting out with a lot of the focus is going to be on water or water-based liquids, and I'm trying to explain why we're starting with that focus. Does that make sense?
Yep, but this is driven from cold plates.
Well, it's also driven from door heat exchanger. Well, okay, to a certain extent. I guess the question ends up being, if you build a
you have a point on the door heat exchanger because they're trying to introduce microchannel door heat exchangers now too.
Okay. So I guess the thing I would say is exactly that point. You don't know if you put in, if at day one you're putting in door heat exchangers, and then 3 years down the road you say, wait a second, can we take that loop and make that loop into a cold plate loop? Um, the filtration stuff is one aspect. Do we actually have to change out and flush and purge? And are the things we need to do specifically to make the liquid better? And you're not going to
So,
be able
so,
to.
so let's go back to the beginning of your scenario. So your scenario with the rear door heat exchanger is cold plate cooled.
Scenario with the heat exchanger right now is starting out with cold plate or door heat exchangers. You're going to be looking at water or PG 25 or
I think you're missing my driver on there. So if you run conventional door heat exchangers, they've got generally large tubes in them,
yep,
and they can handle all kinds of crap in the coolant, and they just don't care.
right.
But and depending on the kind of cold plate you run, if it's a tube soldered to a plate, then and it's an 1/8 inch tube or something like that, then they don't care about how much crap you run through there. So there's pretty much no requirements on how crappy the coolant can be, other than anti-corrosives and biologics and all that other crap that you put in the coolant. But if you went to a if you then changed out your servers and you went to a server that had a microchannel cold plate in it, now you've got a different requirement on the quality of your coolant. So in that case, whatever was circulating, you'd have a pump inside of the cabinet that's circulating between your IT equipment and your rear door cooler. At that point, you would have to either add a filter or put a better filter in it to meet the requirements of the cold plate.
So yeah, so maybe doing this electrical analogy, I guess the question is, can we make the piping solution into a bus bar where you basically, as long as you're all working with the same voltage, then you just have ampacities, whatever, and same thing. Can we make it so you can interchange um, uh, the one solution could be done? I guess one of the key things going back to it here is the supply chain is going to need huge amounts of these items. And if the items are going to have to be, and one of the discussions I am getting from a lot of, I've ran this concept by a fair number of customers, and the industry is liking the concept of looking at the distribution header as being a Lego. Basically, that what you show here is hypothetically a 5 IT rack Lego that you can snap together, has branch lines, is pre-designed, engineered, and
Right.
you
I agree with all of that, but for this particular installation, the coolant quality is going to be driven by the cold plates.
so that would be, if you wanted to, let me put it this way, if you design a solution that can support a cold plate, it likely could also support a door heat exchanger. So if you're dealing with the colo provider, and literally I am having colo providers saying exactly this question. We've been asked on what it will take for us to plug in and add 8 megawatts of liquid cooled IT on demand in the future. And
Right.
oh, by the way, the customer is not clarifying whether it's door heat exchanger or cold plate.
Okay, so say we have an existing completely air cooled installation,
Yep.
and they're 1.5 kilowatts per server, and they start swapping them out for 5 kilowatt servers, and you can't air cool that, so the only way that they can cool that is cold plate. So now you've got to do something like the CDU installation or a rear door heat exchanger or something to dump the hot coolant into the atmosphere. So the if you're trying to talk specifically about the coolant quality, then it really depends on the kinds of cold plates that you start swapping in at this point. So if you've got non microchannel cold plates, then you could run 100 micron or something like that for your filtering in the in-cabinet CDU, and you'd be just fine. And as long as you put that same server in the cabinet, you're okay with your 100 micron filtered coolant. But if somebody goes in there and if it's a colo, and it's all connected to a common rear door heat exchanger or something, and somebody goes in there with a new design of server and it's got a microchannel cold plate in there, then it's the least common denominator kind of thing.
Yep.
Not your
Yeah.
Legos that's going to drive the coolant quality. So somebody drops this thing in there and all of a sudden he needs 25 micron filtered coolant. Otherwise you'll clog the microchannels. So none
So
of the plumbing changes, but the filter that's inside of the CDU, well, actually, it's not a CDU. The in-cabinet filtering and pump on there, the filter, if you designed the pump system well, you could pull out the 100 micron filter and plop in a 25 micron filter. And now 90% of the servers in there are getting coolant that's way cleaner than necessary. But the least common denominator server in there with the microchannel heat sinks or cold plates is now happy with the quality of the coolant that's in it.
So a couple things.
And I would expect the same thing to go with the picture you've got in the top left there. That if you ran CDUs and you ran that out to facility water, your IT side coolant could be 100 micron filtered in the CDUs, and as long as you weren't running any of the servers in the cabinets as microchannel cold plates, you'd be fat and happy and off you go. But if somebody at some time in there goes in and changes to a microchannel cold plate server, you're screwed. You've got to change your filtering.
Well, okay, screwed and changing and filtering could be two different phrases. Okay.
Well, it depends on whether the CDUs are designed to handle 25
There's
micron
the
filtering.
so that's the question, and that's one of the things we'd be looking at is in this discussion group. Number one, I'm only going to be focusing on for the purpose of this discussion, looking at not AALC, but looking at optimizing the integration of a TCS with a facility water header, which ultimately is where most people say they want to be. The AALC is considered a band-aid, as you have some energy loss equations associated with it. Okay.
Well, I mean, it's a really bad idea to dump water to air to water.
Okay. Well, but I don't want to say that prematurely to people that are building AALCs and insult them.
Well, and this is where I get back to it depends on whether they let you touch the water or not.
Well, and so what I'm having is a lot of people, there seems to be a strong industry interest in doing this solution up here.
Which is way more efficient than a rear door or in-row heat exchanger.
But exactly. But let me kind of give you a couple discussions here. Number one, this decision up here, a solution up here, you've already touched on the fact that it is not well defined. And let me ask you, maybe phrase this as a question. What are your sources of contamination of your water solution?
On the IT side, well,
on the TCS side, if you have perfectly cleaned water, what's the sources of contamination?
Anything that's new that's added to the system.
Also, if you have anything that's done, for example, from the pipes perspective, if there's anything that will have a corrosion, some sort of corrosion products added to the solution or scaling or things like that.
Yep. Well, this is where that there is a group, and I forget what they named their group, that's just doing the coolants themselves. And I can't remember whether they were the mineral, the oil-based coolants, or whether they were also doing the.
But here's where I'm going with this: is I've talked to the cloud providers, and the cloud providers are either looking at water with inhibitors,
yep,
or PG25.
Yep.
They are not looking for the large loop. They're not looking at dielectrics at all,
unless they're going to go immersion cooling.
for the larger loops, the larger the loop, the less likely they're going to want to use dielectric as a transportation device. Okay.
Yeah, I really don't like immersion cooling. It's really messy.
Well, I'm not
Yeah,
disparaging immersion cooling,
yeah,
and
it's
there
got
will
its
be
place.
situations there are situations where you if you connected a bunch of tanks together and you have a very short run outside the building, that's fine. But if you actually try to add immersion cooling, let me rephrase this for simplicity of the discussion that I will
Yep,
be hosting, I'm just going to be looking at rack based form factors, okay, and the
yep,
IT based form factors, even if they
yep,
are immersion, are going to have a heat exchanger and go to water. Okay.
yep. So it's either water with biocides and corrosion inhibitors and um, the what's the other modifier that we put in it? I'm brain fading. There's another modifier that we put in the
Right.
coolant.
And when I talked to a very major data center owner, he identified that he wasn't even looking at the PG 25 because this drop off of specific heat from 4.18 to 3.87 was beyond what they were willing to tolerate. So I can tell you
Yeah.
right now, if they're not going to accept 4.18 down to 3.87, they're definitely not going to go
Plus
down.
the added pump running cost.
Well, yeah, so your viscosity ends up being an issue. And then the only other thing without disparaging immersion cooling, if you
Yep,
ever do have a leak with that product,
yep.
you'll never
It's messy.
you'll be skating for the rest of your life. Okay.
Yep.
And
But
that
but in any case, you've got some kind of a requirement for your cooling, and what you don't have on this page is what the filtering level is.
well, and that is a great question because that's one of the things that I was going to add. This is what has been published so far, but filtering has not been addressed by ASHRAE. And when I brought this up to the ASHRAE group, they meet monthly. I don't know if you're on those calls, but I've asked about filtration being listed, and it's still on a we'll get back to it kind of thing. We don't talk about Bruno, we don't have the bandwidth. So, to your point,
Yep.
the thing I was saying though is when you start getting down to 25 micron, you these concept of Legos are essential because I had a GC walk up to me and he said, you know, and actually I had a major operations guy from a social media company, and he said people are defining the pipe, people are defining the IT rack, but they're not defining how to connect the two. And a GC walked up to me and said, oh, by the way, I did drop lines and everything else. No one really gave me guidance around it. And then I was told to rip it out because I used pipe dope and
Yep.
goop on thread connections. Okay.
Yep.
Mhm.
Now, when I say that to anyone on this call, you say, of course you don't do that. But a general contractor doesn't know that.
Yeah.
and
Yeah.
and so this discussion here, what would really help is you're going to have this show up the job site and having any chance of you being able to get to 25 micron and maintain 25 micron. You're going to have to make sure that the entire assembly from these pipes is designed, constructed, and cleansed offsite, and that it is designed in a way that makes sure that you won't have any ionic contribution or water interaction or corrosion product growth. And then when you get at the
Or
job site,
biologics.
or biologics, and you're going to want to, once you get to the job site, you're going to want to make sure that the assembly process has a procedure for keeping it clean. And then you're going to have the flushing process because I'm out of league here, but getting to 25 micron is not simple.
Yeah, I would imagine that you would loop all of the plumbing that's inside of the cabinets together without connecting the servers and run the CDUs for potentially days and probably change the filters a couple of
Okay.
times to get all the crap out of
Yeah.
the coolant and out of the
Yeah.
lines and stuff like that before you'd
Yeah, but
even try.
you'd want everything to already arrive fairly clean.
Yep.
And you'd want it to be sealed, and you'd also want and you need everything from like we said, like the lines there, any hose connections, everything has to be sealed and clean before it arrives, or else
Yep.
you
And you'd
know,
have
if
to be careful with your suppliers so that if they pressure tested your manifolds, that either when they flushed the manifolds at the end of the pressure testing, they flushed it with 25 micron, water or whatever, so that they didn't leave any crap in the manifolds or the pipes or
right,
the plumbing. Right, right.
right.
Otherwise it's a pain in the ass to get it to 25 microns.
Yeah, but this needs to be. I mean, this would make more sense if there were some leadership taken on this, and I don't know where you leave the the creativity so that manufacturers can have something to have them stand out, but there
So
needs to be.
if you're a contractor or a CDU manufacturer or plumbing manufacturer or something, then they probably uh, don't even know that microchannel cold plates are on the horizon, and that going from 100 micron to 25 micron is also on the horizon.
Okay.
So you could write a white paper that talks about the current state of the art versus the future state of the art, and how that's going to drive coolant quality requirements if somebody goes to microchannel cold plates. And then, like we've been discussing here, there's a whole laundry list of best practice things that the component manufacturers can do to make the general contractor's life easier when he plugs all of these pieces together and tries to
Sure.
get it clean.
Yeah.
So we'll call it guidance versus requirements because we don't do
Well, the requirements I think will come out of the cold plate.
well, the requirements will come either out of cold plate or out of ASHRAE. Okay. But what I would like to do, what would make this a productive work stream? If we were to create a work stream around the TCS fluid, and where would we start?
With what the requirements are. So you've already got a set of requirements for what, say we just, kept it at water. From you don't really, I don't think you want this group to define what the coolant looks like as far as biocides and corrosion inhibitors and stuff like that. There are other groups that I think have already done that.
You said that
or
that the group that's doing the fluids, they're not talking about PG25. They're not talking about water or biocides or additives or anything.
I think that they were talking, that was immersion cooling that they were talking about. So it was all
I see.
synthetics and stuff.
Okay, yeah,
And
okay.
the immersion cooling discussion is something I would leave with the immersion cooling sub project. It is entirely their jurisdiction. Does that make sense?
Yep. Until you interact with the CDU that's inside of the immersion cooling tank.
Well, yeah, but again, I'm not going to the CDU that's inside the immersion cooling tank. I'd like to leave that outside.
So you're starting to find scope.
Yeah, exactly.
So immersion cooling is not part of this. So you're talking about water or water derivative coolant based things, not synthetic oil based coolant things.
Well, when you're talking about coolant, is this for single phase? Is for pump refrigerant to the chip as well, or that's another part of the scope that might be
the
best
pump
to...
refrigerant. Well, I don't think that can be included in here. Pump refrigerant, once again, it's a unique beast. Where and by the way, I say this with deep respect for the wonderful people at Vertiv. Okay. But I guess the question ends up being if this is to be useful, we're going to have to define boundaries around this discussion that address an industry problem without being exclusive. Okay. And pumped refrigerant, because of the fact it's using refrigerant, we're focusing on water-based liquids, and I think we'll start with that. Not to say that in a pumped refrigerant situation, obviously you're not using water-based unless you're trying to use water.
Yeah, I agree. I'm trying to help set the scope of this. This is
okay.
It's not immersions, no, it's not about immersion. It's not about two phase. It's about a single phase,
Water-based liquids, right?
water-based liquids.
I'll refund it with a better way to
Not immersion, not two phase. I wouldn't even call it refrigerants, just call it two phase.
well, it's the same thing. Any liquid
okay.
is a single until you make it go to two phase. It's a liquid.
Well, you can make water
But-
two phase, but you ought not to.
It could be a refrigerant. Water can be a refrigerant. Yeah. So, but we're not going to be doing that pressure range. So anyway, so then what are we trying to?
And I don't. Well, I think you can depend on ASHRAE to define the coolants and the material compatibility and stuff. So I don't think you need to define
material compatibility. You're right. Material compatibility should already be defined by ASHRAE, or might be defined by the cold plate group already, right? I think they would have a material compatibility. So although I don't know that the filtration is actually defined by, if the cold plate OCP is defining a standard for filtration. I think that's open to manufacturers to go down to whatever filtration that they deem necessary, isn't it? I haven't seen any.
I think the microchannel cold plate is something that's kind of new, and both for rear door coolers and for cold plates. So everybody has been depending on So where you are right now kind of splits a little bit on what this guidance needs to look like, is really dependent on what the cold plate looks like.
So I guess the question ends up being, when your filtration drops from say 100 down to 25, and what I have heard, and let me kind of there's another document. By the way, are you seeing my what screen are you seeing?
Your notes.
I'm seeing your screen, your notes.
Okay. There was a guidance put out by LBNL directly around this, and we may start with a review of that. I may send it to you guys. I'm trying to think. Let me just go off.
Send that to me. I'd like to see that.
I'm going to stop sharing. Oh, I thought I was going to stop sharing. How do I do that? Not doing it very well.
Scroll
There's stop share. Okay.
Yeah.
What I didn't want you to see is all my family pictures as I try to find a document here. But there's actually a cold plate loops. Okay, so cold plate came out with a loops requirement document. I'm going to call that one up. And then there was also a where is that filtration thing? I'm not going to find it right now, but they actually did a good job of defining this, and I don't want to. I didn't come prepared for this right now. Let me just show you something real quick, and I will go back to Sharon. Michael, you might have already been part of or seen this here. Let's see. Go back to every one of these applications has a different way of sharing things. So I guess you're not seeing what I want to be sharing right now. So how about this? So this is one document we'll be looking at, which is the cold plate cooling loop requirements document.
Yep, so just for glycol.
Yeah, well, it kind of
treated water and glycol.
Right. So they basically, ironically, this table here came about the same. I mean, I came up with one, they came up with one, and our formatting actually ended up being the same. I'm not sure what was the source, except for I was a little more specific. Instead of saying thermal performance was high, I actually gave specific heats. And what you end up with is that's the 4.18, and the this discussion here, amazingly enough, these two tables were done independent of each other, but they do have a similarity to how we looked at, in terms of we looked at that and we looked at this. Maintenance schedule is an interesting aspect. I don't know. Maybe you need to dive into what treated water, why that has a high maintenance and PG has a medium maintenance.
Probably the probability of oh, this has got biofouling as medium versus low. And that's probably the only difference between the two.
Well, can't you put something in the treated water?
Yeah, you can put, yep, you can put biocides in it.
So just so you know, one of the other invitees I would have to this work stream is this organization called NALCO. Are you familiar with NALCO?
I've heard the name.
Well, they deal with water treatment, and so they actually have a paper on recommendations for things. Let me take this. Let's go back to the real quick overview. What I have to do is somehow, my goal is to have something that helps people understand, and maybe we'll talk about the difference between how you approach 100 micron versus 50 micron versus 25, with an ultimate goal of being because part of it ends up being you may put in what I had read with the Lawrence Berkeley National Lab is that you basically go with 50 micron filtration and a side stream filtration of say 5 or even 1 micron. So what you end up doing is your main flow is going to go through one filter, but you're going to, by repetitious flushing, you're going to eventually get your filtration well below that. Does that make sense?
Maybe in the short term, but I'd be worried about long-term corrosion and biologics and all kinds of other stuff that are going to grow in the water.
Yeah,
well, that's the other area
didn't
that
actually
ties
catch that.
into this is if does long-term corrosion, long-term biologic, if you limit your pipe material type to say stainless or CPVC or HDPE versus
Then you're all back to material compatibility.
when we say material compatibility, what would be the material compatibility issue with say stainless?
You're talking to the wrong guy. So
No, that should be fine.
Yeah.
There's no issues with material compatibility for stainless as long as you got the right grade, 304 or higher.
Yeah,
but
so
that's something that could be in the white paper is just what you said, is that what plastics are okay, what metals are okay, and so you've got a material compatibility issue for biologics and corrosion for long term on there.
This is why the more of a Lego approach you can take, the less risk. And let me give you an example. A paper was cited by, I think, John Minash, who works for some stupid company. What company does he work for? Right.
I think he works for my company. Yeah, I think he works for my company.
And he was mentioning that there was years ago a IBM document that identified a problem where I think they had an ionic incompatibility because they were using the wrong type of brass. Okay. And so now they have specified what type of brass. But fundamentally, what I'm saying is as you look at all the components that go into a branch line, everything from the isolation valve to the balancing valve or PIC valve, PIC valve, to the cabling, to the connection, to the quick disconnect. Those, if they are
You've
defined,
got a lot of options. You've got a lot of options out there.
Yeah, so if you can come up with one option that's been pre-tested and pre-engineered, then that actually saves the life of the contractor. He doesn't have to make those decisions on the job site, and he doesn't have to put his oily little fingers in the system. It's all snapped together. So that would be one area that we're looking at. So I don't mean to. One of the challenges I have is in my job, I deal with pipes and liquid distribution. I go to bed thinking about this stuff on a regular basis. You guys have to think about a whole lot of more stuff. I just have to think about pipes. And so when it comes to these topics, a lot of them I've been thinking about a lot. And I need to put together a work group where we have people like yourselves and maybe some others. I'd like a smallish size focus group and maybe just set up a meeting in 2 or 3 weeks or something like that to help scope out what would be a useful discussion stream that would help our industry. Does that make sense?
Yep. But and part of this is the initial installation cost versus preparation for future requirements. So if somebody is building a water-cooled system and they're using conventional cold plates now, then they can end up with a lot of crap in the coolant and doesn't matter in the least. But if, like I said, somebody swaps one of the servers in there for something that's got a microchannel cold plate on there, and the whole coolant system needs to be a lot cleaner than it ever has been. And if they haven't, and you need this laundry list on there for everything that's in the IT coolant loop that could challenge your move to go from, say, 100 micron to 25 micron coolant. And whether the and it even depends on whether the filtering system that's inside of the CDU is even capable of accepting, a 25 micron filter. So if they ended up not paying attention to material compatibility, and they've got some of the plumbing in there that's starting to shed crap into the coolant, you'll never ever get to 25 microns.
So I love the discussion. This would be something, again, we've taken in a call that wasn't even happening. We've already taken 52 minutes of it. But I think what you're saying is, if you started out, say you're doing door heat exchangers, and you say your filtration requirement, you're going to set that as 100 micron, okay?
And so you've got conventional cold plates and a conventional rear door cooler. Right.
Is it possible then, when someone says, "Oh, I want to add microchannel
cold plates"? Yep.
Cold
so
plates.
they swap a server out to something that's higher power.
It'd have to be the whole loop, I would gather. Okay.
Well, I mean, if you've got 25 servers or something like that in the cabinet, cooled by a single rear door heat exchanger, plus a pump that's inside of the cabinet, everything's happy with the existing design. So now they want to upgrade one of their servers. They yank out a server, they plug in a new server. It's got the same electrical connections, the same network, the same coolant connections. But if the new server is now got a microchannel cold plate in it, you're screwed.
Screwed is a relative term.
Hold on, Don. I think I might be missing something that you're bringing up here, because you're saying that you need to pull out the whole loop, and I'm with Mike, where if they were going to add a microchannel server that's like 50 down to 50 microns or 25 or whatever, I don't know that you'd have to pull out the entire loop, but you would have to go back to your
filtering would have to improve.
So you'd have to go back to where your filtering processes are, and see if, like we had said earlier in the conversation, either needs to change at the CDU, or you'd have to. I don't think it's a good idea. I don't think that's the right way to go, but you'd have to figure out some way to filter it after the door into the.
But if everything inside of it had good material compatibility, and your biologics and corrosion are all under control, and you've got a filter,
stay the same.
And you've got a filter inside of your pump assembly, and so that you could change it from a 100 micron filter to a 25 micron filter, you'd probably have to let the system run for a week before you could swap the server.
Okay. So what you're saying here, one thing I did kind of stupidly throw out was, I was talking to this operations engineer from this social media company, and I said, "What about local filtration?" And he about died laughing. He said, "How are you going to do the maintenance on swapping out all the friggin' local filters for all your servers?" Okay.
Well, exactly. That's what I meant by, I don't think it's a good idea, but you'd have to put filtration further down the line after the door. And how are you gonna? I mean,
well, now you got two filters. You got one inside of the pump assembly, and then one someplace else.
Right. And one's going to be collecting junk all the time, because you had said, Mike, you didn't kind of take it all apart, run it through, filter that out. So you're going to have a lot of issues. That's what I see. So you have to go back and clean out your fluid, maybe just actually just dump the fluid, put in new fluid, and change the filter at the CDU.
Yep. So if the pump assembly was designed so it could work in a 25 micron environment and would accept a better filter, then you could conceivably, like you said, put a new filter in it, dump the exchange the coolant, and I would let it run for a bit before I put the microchannel server in.
So,
And
well, there's testing that can be done as well to validate that the that the fluid is at an acceptable level.
Yep. So days, hours, whatever it is at that point, and then now the coolant is at 25 microns. It's safe to allow the coolant to go through a microchannel cold plate. So now you can put your new server in, and you're good to go.
So I guess the only thing I would jump back to is CDU design, going from say 100 micron filter down to a 25 micron filter. I'm going to guess that you have a certain amount of head loss in the 25 micron filter, as in not just guess.
Sure.
Yeah. Well, that's what I mean. If you're, it's probably not a CDU if it's got a rear door heat exchanger and it's in a cabinet. It's just pumps.
Well, first, again, I'm not looking at the rear door heat exchanger in a cabinet. I'm looking at the a loop-based solution set.
The whole system, right?
Right. But if they were doing a migration, this would be, let's say, step one. And then if they started to scale this thing out a bit, so now they've got 25 cabinets that they want to do this, you're not going to do a rear door heat exchanger. You're probably, I mean,
right. So I'm
this document.
This is the scope that I'm starting with is this.
Right. So rear door heat exchangers aren't even in the discussion at the.
Not at this point. I'd like to.
I see.
This is the problem that. Let me rephrase this. Selfishly, I'm seeking to answer problems that are being brought to me. Okay.
Yep.
And in a open manner, in a way that I think the participants would see benefit. And I literally am having.
So if you're in a,
go ahead.
If you're in a megawatt system, you're a CDU and you're using facility water.
On one side.
Right. And then you've got some amount of cleanliness in your IT side coolant. And if you bought CDUs that were capable of running in a 25 micron environment, but potentially you set this up initially with 100 micron filters in it because that's all you needed for your existing servers. Now you got crappy coolant in there, and if your biologics and corrosion is under control, then you could swap the coolant and swap the filters and run it for a bit. Do your magic on your coolant to say that it's to see that it's down to 25 microns cleanliness on there. Then you could start upgrading your servers with ones that have microchannel in it. But if you never put microchannel cold plates in any of your servers, then you could stay 100 micron for the rest of your life, and you'd be fat and happy.
Well, go ahead.
So Don, one thing I gotta hop off real quick or pretty soon. But one of the things I'm thinking is for the piping, as long as we have the wetted materials correct and it's sized correctly, then and maybe sizing it might be what kind of flow rate and pressure do you need for a 25 microchannel cold plate versus a 100 or 50 micron cold plate. I don't know.
And assuming the pumps that are inside of the CDU were designed to run in this microchannel, right?
But I think maybe it might make sense to look at what sizes are needed for the piping, and that might be an area of focus because the wetted materials that should be completed. And that should be done at this point. We should have that, right? So that I think that's done on the cold plate. Now for how can these pipes come together and we have something that makes sense and works together? I think you need to go towards so you have pipe size on here, so that's where I'm kind of seeing a TCS loop for OCP. It might come down to these type of connections and this type of what a material that's already been called out and at these sizes, based on, you know, if the customer thinks in the future they might want to go to it down to 25 microchannel, 25 micron versus, you know, the 50 or the 100 where they're at now, that's something that, you know, the white paper can answer, or some that's kind of
Okay.
It would be
that's what
it
I'm
would be
thinking.
interesting. It would be interesting to see a spreadsheet with only two columns in it. One column is 100 micron and one column is 25 micron, and run through all of the requirements on there for pumps and filters and plumbing and everything like that that might be different between the two.
Yeah, a lot of those rows are going to be the same.
Yes.
A lot of them would be the same, but
it would be
yeah,
interesting to see if there are any financial considerations between the two.
Yeah, and
And
I think
then
that might be where this working group and eventual paper, I think that's where you want to have the focus and the emphasis there.
Yep, and it might be challenging to get somebody to spend an extra 10 or 15% on CDU and plumbing cost for the provisioning for 25 micron in 5 years or something like that.
That's a good point. Yeah, and then through that paper, 50 micron standardized.
Yeah.
It becomes a standard in the industry.
Well, what I have heard is a trend toward 50 as being the highest that you would go with data centers. But I don't want to jump to that. I'll let people. I'll just say versus.
But you need to talk to somebody who's making microchannel cold plates and see what their requirements are.
So then we also need to get, in terms of participants, probably Dell. I mean, although they don't make their cold plate,
I thought IBM was.
Yeah. You wouldn't do Dell for cold plate. You could do like well, Cool IT makes cold plates. You could do Micros is another company that makes cold plates. We're familiar with them. MIKROS.
Micros.
There's also, I think there's also another company called Jet Cool or Cool Jet or something. I can't remember now. But
so, Bennett, would you be either interested in sharing recommendations of invites, or would you want to take it on yourself to invite those people?
Yeah. We could put something together. I can be a part of that.
Well, what I would say, so look, time window, if we look 2 or 3 weeks out, what we're looking somewhere actually the week of SC23. Are you guys going to be there?
Yeah, I'm going to be at SC23. Yes.
Do we want to? I could host a call live and there sometime. Are you there? Are you busy the whole week? Are you working that show?
Yeah, I'm working the show. So I'm probably not a great
following week is what we call Thanksgiving, which may be a great week to have a call, like the 21st, because no one's doing anything. They're on vacation. I don't know.
Other than being in a turkey coma.
Well, how about
I'll be on vacation.
What about the week of the 5th, sometime around the 9th or 10th of November?
Next week? 2 weeks and 2 weeks.
The week after next.
Yeah.
Next week.
Actually, the supercomputer conference is probably not a bad idea, because you'll probably have representatives from all of the people that you would need to talk to there anyway.
I'm just trying to figure out, I'd either have to get a room or I'd just do it virtual and have people figure out how they're going to get their own rooms. And my budget doesn't allow me to get a room.
I still think all of this is going to come out of the cold plate people.
It will, but it's something that other groups need to also. I'd like it to be cold plate and door heat exchangers. I see a symbiotic, and even
there is there is a discussion about microchannel rear door heat exchangers.
And then the other thing, I'd even include
hey guys, I'm sorry, I got to drop.
Okay,
but good discussion. Thanks, guys.
I'll drop you guys both a note. If you don't hear from me in the next 24 hours, then it means something. I didn't get your email address or something. I'm pretty sure I have both of your email addresses. So thanks a lot.
Okay. All right.
Okay.
Thanks.
Thanks a lot.
Well,
bye.
See ya.